4 cosine 2 theta equals negative 12 cosine of theta minus 8. Now the way you're going to need to work on this is to first of all write everything in terms of sines and cosines. So going all the way back to section 3.6, we had 3 different formulas for the cosine, or the cosine double angle. And you've got a cosine double angle here. So which one do I want to use? Well, if I'm trying to write everything in terms of cosine, and that seems to make sense because of the cosine here, then I probably want to use this version right here. That is 2 cosine squared of theta minus 1. So let's use that. 2 cosine squared of theta minus 1 equals negative 12 times the cosine theta minus 8. All right, not so bad. Now there's 2 possibilities here for me, and looking back I could have done this earlier, but I'll do it here. I can either distribute the 4, or how about if I divide everything through by 4, just to make my life a little bit more friendly. Those 4's there cancel. That gives me 2 cosine squared of theta minus 1. 4 goes in there 3 times, so negative 3 cosine of theta minus 2. Let's push everything over to the left-hand side. So that's going to be 2 cosine squared of theta. When this comes over, it's going to be a positive 3 cosine of theta. Negative 1 plus 2 is 1. Equals 0. That's what I wanted. Basically, this is a quadratic equation in cosine of theta. So there's a little trick that we did solving this a while ago, and that is we're going to replace cosine of theta with u. So this is going to be 3u. And then this will be u squared. And the reason I'm doing that is because it's going to help me factor it. I'm much better at factoring quadratics in u as opposed to quadratics in cosine of theta. So that's going to factor as a 2u and a u. And then, well, let's see. There's not much I can do to get 1 other than have a plus 1 and a plus 1. And I'm sorry that there's a flash on the screen there intermittently. I'm not sure what's causing that. Let me finish up. You've got something times something equals 0. So either u plus 1 equals 0 or 2u plus 1 equals 0. That means u equals negative 1/2. This means u equals negative 1. And that's great as far as it goes. Remember, we're trying to solve for theta. And u is taking the place, so we're going to let u equal cosine of theta here. We did that up here. Now it's going to come back to us here. This is cosine of theta equals negative 1. This is cosine of theta equals negative 1/2. This one, I hope you know. Where does the cosine reach its minimum? What angle do you have an x-coordinate of negative 1? Pi. Yay. And then the other part is theta is the inverse cosine of negative 1/2. And there's actually 2 places that have an x-coordinate of negative 1/2. So let's look at our unit circle. And that's here. Let's kind of zoom out a little bit. View. There we go. So I'm looking for places on the unit circle with an x-coordinate of negative 1/2. I see one right here at 120 degrees. But where's the other one? Yeah.
240.
240. Good. So right here and down here. Both of these have an x-coordinate of negative 1/2. Now, if I'm answering in radians, it'd be 2 pi over 3 and 4 pi over 3 would be the correct answers here. just take a look at what you're being asked. Is it degrees or radians? So 2 pi over 3 and 4 pi over 3. So a total of 3 answers if you're working in the interval of 0 to 2 pi. Sweet.
Would there be like a problem like this that would like specify like if it was in like quadrant 2 or 3, like it only wanted one of those?
It's going to say that theta is between 0 and 2 pi, so you would have to give all 3 answers. Now what you wouldn't have to give would be, say, let's see, adding 2 pi to that. You wouldn't have to give 8 pi over 3. 8 pi over 3 would satisfy this, but it's not in this interval, so you can ignore that. You can just work with these. But that's going to be the restriction on your solution here.
Okay.
Anything else? All right, good luck with these.